Ohanian 5.74. This is the problem where you've got a couple of ideal pulleys and you have a mass 1 on the left of this one attached to another pulley where the left side of this rope is attached to the floor, and you have a mass M2 hanging from the right of that. Well, this is intimidating when you first see it, probably, not least because it has a double asterisk, which means it's supposed to be a hard problem. So after a minute of panic, we'll all try to approach it systematically using our methods for solving Newton's laws problems. And this is, I hope, pretty clearly a Newton's laws problem. You're given M1, M2, and presumably you know G, the acceleration of gravity, and you're asked to find the accelerations, let's call it, of the two masses, so we'll just call that A1 and A2, the acceleration of mass 1 and the acceleration of M2. Okay, so that's the question mark. So let's approach this systematically, like I said, and apply Newton's laws to each object in the system. Okay, and you were given some hints in the problem, which I'll use when I write this out. But let's start by agreeing that we'll call plus y the up direction for everything. Now, you might want to do different things left and right, etc., but I just want to do it this way for now. Okay, so for mass 1, what are the forces that act on it? There's M1G down, and there's this first tension in the string. Now, there are two strings involved. They could have different tensions, so I have to allow for that by calling this one T1. How about the pulley? Pulley 2. The one up above we don't care about. It's not going to do anything interesting. It's not moving. But this pulley moves, although it has 0 mass, and we'll use that. We still need to worry about this pulley because it connects the tensions. It has T1 from this rope acting up on it. It's an equal and opposite force for the T1 pulling up on that mass. And an ideal string has the same tension acting on both ends, always pulling in. But meanwhile, we have a second string and a second tension acting on this pulley, again pulling down on both sides. So these are the three forces acting on that second pulley. And we have another mass, M2. And the forces acting on it are the tension pulling up, the external forces acting on it, tension pulling up, and M2G down. So we have three free body diagrams, which means, and we have only one dimension to worry about, y direction. Okay, and so we can write down 3 Newton's laws problems for this. So let's start with the sums of the forces in the y direction on M1. Okay, just look at our free body diagram. Well, that's T1 in the positive y direction minus M1G. That has to be equal to M1A1. Good. How about the sums of the forces on pulley 2? That will be the tension pulling up in our positive y direction and 2 factors of T2 pulling down. But those have to sum to 0. It's actually the mass times the acceleration of this pulley, but the pulley has 0 mass, so those have to sum to 0 because the pulley is massless and can't have infinite acceleration. How about the sums of the forces in the y direction, it's also y, on M2? Then I look at my free body diagram, I say, I've got T, I should have labeled this T2 pulling up, minus M2G pulling down, and that's equal to M2 times acceleration of 2, which is different than the acceleration of 1, but at least potentially different, and that's the next thing we have to work out. What's the connection between the motion and the accelerations of those two objects? And this is where it's easy to get confused. Perhaps it might help you to think about this. What if the rope was actually attached to the ground on both sides and you tried to move the pulley up by a distance y, then I think it's pretty clear the rope would have to stretch by 2y. So any motion of this pulley would give you twice the motion of the rope. Now in this case, the right end isn't attached to the ground. It's free, but you still would have to have this end of the rope move up by then twice the distance the pulley moves up because it's not stretching, it's fixed in length. And this end is fixed to the ground. So that tells us that A2 has to be equal to, now notice if the acceleration of this is in the positive direction, okay, then the acceleration of A2 is equal to negative A1, because actually I should say a positive acceleration for M. The acceleration is not of this pulley. That's not what we're worried about. The acceleration is for M1. So if M1 accelerates up, okay, and then that means this pulley's falling and M2 accelerates down. That's the reason for the negative sign here, and we've already explained the factor of 2. Likewise, if M1 goes down, then M2 goes up, okay, and I've considered the plus y direction as positive upward for both of them, so I need the negative sign. So we now have 1, 2, 3, 4 equations, and we also have 4 unknowns. We've got the tension 1, tension 2, and the 2 accelerations, but all we're asked for is the accelerations, which means we'd like to eliminate the 2 tensions from the equation. Okay, so how do we do that? Well, this is where you have lots of choices for how to solve it. It's now reduced to an algebra problem. So let me start this algebra problem by eliminating A2 from this expression, because I have A2 equals 2 minus 2A1. So I can take this and replace it by T2 minus M2G equals, instead of M2A2, I have negative 2M2A1. I replace A2 by negative 2A1. Likewise, I can take this equation and I can use the second equation to eliminate or replace T1 by T2 here, because T1 equals 2T2. So this becomes 2T2, okay, minus M1G equals M1A1. Okay, so now I note that, okay, I can eliminate T2. We don't want T2 in these expressions. So I can eliminate T2 from these by multiplying this equation by a factor of 2, and then subtracting it, okay, from this equation, minus that. Because then I'll have T2, 2T2 minus 2T2. And so these will cancel after I do the subtraction, okay? And I'll have 2 times M2G, so let me write that out. I'll have minus 2 M2G, minus a minus 1 mg is a plus M1G, equals, and I'll have 2 times this, which is minus 4 M2 times A1. Let me just group them together. Minus 2M, or minus M1, not 2, minus M1 times A1. And I can then rewrite this expression in terms of A1. Just divide both sides by that factor. So I have solved for A1 equals 2M2. Okay. Notice these are both negative, so I'm factoring out a negative here and changing these, dividing both sides by negative or multiplying by negative 1. So that will change the signs of these two. So 2M2 minus M1 divided by 4M2 plus M1 times G. Okay, and the acceleration of the pulley itself is going to be, by the way, negative A1. Okay, it moves at the same acceleration as M1. So A pulley, if you care, equals negative A1. We're also asked for A2, and how do we get A2? Well, that's relatively straightforward, because we have this expression here, A2 equals negative 2A1, so which is negative 2 times this thing, minus M1 divided by 4M2 plus M1G. So I have the answers that were requested, but now I want to stop and see if they make sense. Sorry, move that up. I want to stop and see if they make sense. Think of a situation where I think I know the answer. Well, what if M2 goes to 0? If M2 goes to 0, and this pulley is 0, that means this mass is hanging free and it should just accelerate down with the force of, or the acceleration of gravity. And what we see from our equations here, for A1, if M2 goes to 0, then this is 0, this is 0. We have A1 equals negative M1 over plus M1, or negative 1 times G. Remember, we called positive up. So in fact, we want this acceleration to be negative G. And so good. I have some more confidence in my answer.